Something I want to stress to you guys is that the graph of an absolute value function, similar to this, is going to look like a V shape. So I'm going to graph what a basic function should look like. That would be with no transformations. So all of your graphs for this standard 9, should be of a V shape. When we do our transformations come from different parts of the function. So in this particular function, y equals a times the absolute value of x minus h plus k, each of those things represents something different. So the first thing we're going to start with is the h. What does the h represent? That number inside of the absolute value brackets after the x is either going to tell you whether it's moved to the right or to the left. This one is the tricky part because if it's right, it's actually going to be x minus the number. And its move to the left is going to be when it's x plus a number. So the thing you want to remember is that if it's inside the brackets, it's going to be left or right. The next thing that I'm going to be looking at is the k value. The k value is going to be whether it moves up or down. If that k value is added, if you have plus a number after the brackets, it's going to go up. If it's subtracted, it's going to go down. And the last part that we have to look at is the a. The a is going to tell us a couple of different things. The first thing it's going to tell us is whether it is a vertical stretch or vertical shrink. This you have to be very careful with because we're talking about the value of a without the sign on it. So basically we're saying the absolute value of whatever a is, and we're going to compare that to 1. So if the number part of what's in front of the brackets is bigger than 1, it's going to be a stretch. If it's less than 1, it's going to be a shrink. And we'll look at that in our examples. The other thing that it's going to tell us is whether it is a reflection or not. The reflection comes when you have an a value that is negative. So these things are really important. The h and k are going to be what we start with. Once we've written out our transformations, that's going to tell us where our starting point is. And then we're going to treat with the V shapes the a like it's kind of a slope. So if it's a positive slope, you're going to go up and to the right. If it's a negative slope, you're going to go down and to the right. So let's walk through the steps to doing the graphing of this. The first thing you're going to have to do is you are going to determine the coordinates for the vertex, and you're going to plot it. The vertex is going to come from the left or right and the up or down. The x value comes from the left or right. The y value comes from the up or down. And what I mean by the vertex is the corner of your V shape. It is that first point that you're going to plot. So you're going to go left or right, and then you're going to go up or down, and you're going to plot that first point using these transformations. So we figure out what the original vertex is. The original vertex should be 0, 0. And then you have to figure out where does it end up. Then you're going to use the slope on the right side of the vertex. So whatever it happens to be, positive up and right, negative down and right, and then you're going to mirror that new point on the other side of the axis of symmetry, or on the other side of the vertex, because it has to be a V-shape. If you don't mirror it correctly, you will end up with the wrong graph. So here we have an example of an absolute value function. So the first thing we're going to do is figure out what are our transformations. Since it's x plus 1 inside the brackets, it should be left 1. In this particular problem, that's the only transformation we have. So what we have to think about is we're going to start at 0, 0, and from there we're going to move left 1. So our new vertex is going to be at negative 1, 0. So now that we have the new vertex at negative 1, 0, we're going to use our slope. So if we look what our slope is, do you see a number in front of your absolute value brackets? There isn't a number, so what number do we assume is there? We assume that it is 1. So we have a slope of 1. So from our vertex, we're going to go up 1, right 1. So remember, our vertex is right here. So we are going to mirror this point to the other side. So you want to kind of think about there being like an invisible line right here. If you want, you can draw it in. And then you're going to mirror the point onto the other side of that dashed line to get that V shape. And once you have your points, we're going to go ahead and graph. So there's our graph of our first function, y equals absolute value of x plus 1. For the domain, remember, is x's. If you look, could we continue this graph all the way to the left and all the way to the right? If we can answer that yes, then the domain is going to be all reals. And kind of a hint, the domain for these will always be all reals. The range is going to be based on how far you go up or down for your vertex, and then it's either going to be greater than or equal to that number or less than or equal to that number. In this case, do we have a low point or a high point in this graph? If you look, this point is a low point in the graph. So for our range, it's going to be compared to the y value of 0. Now, are all of our y's greater than 0 or less than 0? Our y's are going to be bigger than 0, but 0 is included, so we better underline that inequality sign. So hopefully you don't have any questions on that one. So let's try this one. Watch as I go through and do my steps. First thing I have to do is figure out my transformations. So our vertex here is going to be at 0, negative 5 because the only transformation we have is down 5. So I'm going to go ahead and move my x-axis up so that I can graph this. So I'm going to start at 0, negative 5. And again, the number in front of our absolute value bracket is a 1. So since our slope is 1 from our point, our vertex, we're going to go up 1, right 1. We draw on that dashed line if you choose to, and then we're going to reflect it on the other side. So now our domain, again, is going to be all reals. For our range, we're going to look at the low point, which is our vertex. Again, this is a low point because it's open up. And that y value at that point is negative 5. So then we're going to compare it. Are our numbers bigger than negative 5 or smaller than negative 5? So all of our y values are going to be greater than or equal to -5, because this is -4, -3, and so on. So let's try another one. Here we have one that has a number in front. It has an a value of something besides 1 this time. So let's do our transformations. So this graph isn't going to get moved left or right, and it's not going to be moved up or down because there's nothing in with the x and nothing after it. So we're just going to have a stretch. So our vertex should be at 0, 0. Now this time we have a slope of 2, which means we are going to go up 2, right 1. And then we're going to reflect that point over that dashed line that I just drew. And then we make our V shape. For our domain and range, domain again should be all reals. Range, we're looking at that low point since it's still open up. So our domain, we're going to have all reals. Range is going to be y is greater than or equal to 0. Because our graph is not going to go below the x-axis. Here's one that's a little more complicated. There's a few more steps to it, so let's walk through the transformations first. First, we have the x minus 3. Remember, inside is the opposite. So if you're going to do x minus 3, that is actually a move to the right 3. And then that negative sign in front is kind of like saying -1. So there's no stretch or shrink because the absolute value of -1 is 1. But since it's negative, it is going to be a reflection. So since we're going right 3, but not going up or down, our vertex is going to be at 3, 0. Now we have a slope. Looking at this, we talked about that being -1, a slope of -1, which means we're going to go down 1, right 1 for our first point. And then I draw my dashed line, so I'm going to reflect that point that I just had over that green line to get the other side of the V. So this time we're looking at one that opens down, which means this is going to be a high point, and our y values are going to start at 0 and then get smaller. So our range is going to be y is less than or equal to 0. So it's going to be less than or equal to 0 whenever you have a reflection. A reflection will be less than or equal to whatever the number happens to be. Maybe 0, maybe something else, depending on if you had to move it up or down. So let's walk through this one. Take it a piece at a time. Sometimes you can do, some people will do left and right or up and down first. I'm going to start from the left and move my way to the right. So I'm going to start with the 3/4. The 3/4 indicates that it is a shrink because 3/4 is less than 1. The +1 in here, remember opposite, so that means it's going to go left 1. And that -4 at the end means it's going to go down 4. So then we are going to use the left 1 and down 4 to find our vertex. So if you start at 0, 0 and you go left 1 and down 4, where would you end up? So our vertex should be at -1, -4, because you went left 1 and down 4. We are going to next use our slope of 3/4. That means we go up 3 and right 4. Then we draw the dashed line that's kind of the middle of the V, and then we're going to reflect it on the other side. So if you notice, this point right here is how many spaces away from the green line? 1, 2, 3, 4. So we're going to go 4 spaces on the other side. So then the only other thing we have to do now is we need to do domain and range. Domain, once again, is all reals. For the range, the number part is going to be the y value of your vertex. So the y value of that would be -4. And then we have to decide, are the y values going to be bigger than -4 or smaller than -4? If we look at our vertex, are the points above that or below it? In this case, they would be above it, so it should be greater than or equal to -4. We also know that it's going to be greater than or equal to because did we do a reflection? We did not, therefore, it is going to be greater than or equal to. Less than or equal to only comes from when you have a reflection.